Hello and welcome to this video. So today we will be discussing and giving a brief description on ellipses, then we'll be solving a real-life sample problem, applying the things we've learned on solving for an ellipse, and then I'll be giving my reflection on the topic. Now let's get started. Firstly, let's do a quick recap about what an ellipse is and some of its basic parts. So an ellipse is a set of points in a plane in which the sum of the distances from two fixed points is a constant. So these colored dots right here already correspond to these colors on this ellipse and graph right here. So the two fixed points are called the foci. The line in which the foci is located on is the major axis. The line perpendicular to this is the minor axis. The chord that passes through the foci and perpendicular to the major axis is called the latera recta. And these are your vertices, which are the points of intersection between your ellipse and the major axis. These are your covertices, which are the points of intersection between your ellipse and the minor axis. Okay, now to our sample problem. So here is our problem. Let me read it out real quick. A semi-elliptical archway over a one-way road has a height of 9 feet and width of 36 feet. Your van has a width of 12 feet and height of 8 feet. Will your van be able to clear the opening of the archway? Now, I've already pre-made my illustration over here. So here's the semi-elliptical archway, and here is our van. And to help us solve this problem, we can input the given from this problem into our graph or illustration to help us better visualize and see how everything goes together. Okay, firstly, the width of our semi-elliptical archway is 36 feet, but I've divided it in half from the center, so it's 18 feet or 18 units away from the center on this side, and same goes for the other side. The height of our archway is 9 feet, or 9 units away from the center. Same would go for the bottom of this graph if this were an entire ellipse. The width of the van is 12 feet. But I went ahead and divided it in half from the center as well, so both of these points are 6 feet or 6 units away from the center, still creating a total of 12 feet. Now what we're trying to find in this equation is the height of the semi-elliptical archway 6 feet or units away from the center, which would be this point. As you can see here, we already have our x, which is 6, and now we just need to find our y. And the goal of this is to see if the height of the archway will be more than 8 feet or more than the height of the van, because if the height would be less than or equal to the van, then the van won't be able to pass through the archway. Okay, now let's figure out our equation. From what we can see in our graph, it is clear that our major axis is the x-axis, and our center is at the very middle, which is simply the origin, or 0, 0. Now we can determine between these two given that our equation is going to be x squared over a squared plus y squared over b squared equals 1, which is the standard equation of an ellipse given that the major axis is at the x-axis and that the center is just at the origin, or 0, 0. Now once we've figured out the equation we'll be using, let's now get the given that will be substituted into this equation. First is a, which is distance from the center out at the major axis. So the value is going to be 18, or half of the value of the major axis. Now we'll be finding b, and we're going to take the distance from the center out at the minor axis. And this time it's going to be 9. So putting our values into the previous equation, we'll have x squared over 324, or 18 squared, plus y squared over 81, which is 9 squared, equals 1. And what we're trying to find is the y value, 6 units away from the center. So our x here is going to be 6, or 6 squared, which is equal to 36. And then what we are trying to find is the y value. Once we have all the given values plugged in, we can begin solving. So first is to clear out our fractions by multiplying both sides of the equation to the least common denominator, or 324. And then we distribute. Next thing to do is to transpose this to the other side so we can isolate the variable in one side. Combine like terms. We then divide both sides of the equation to 4, so we are left with y squared equals 72. And to get rid of the square, we squared both sides of the equation, leaving us with our final answer, which is y equals 6 square root 2, or 8.49 feet. Since 8.49 feet is more than 8 feet, which is the height of the van, it will be able to clear the opening of the archway. And this is our real-life application of ellipse. Now to my reflection. So after doing this activity, I've realized that I'm able to understand the topics better if I try to teach them myself. This has helped me to know another learning style that I can possibly put to use in school. With ellipses, I think our lives unknowingly revolve around them. Literally, our solar system and the planets in it orbit around elliptically. I can see how we can put this topic to use in real life, and I wish to familiarize myself more with it. So that is it for this video. I hope you learned something, and I hope I was able to explain things well. Thank you for listening, thank you for watching, and until next time, bye-bye.